create a calibration relationship between electrical conductivity and total dissolved solids, we're first going to need to download some water quality data for a gauge of interest online. The gauge we're interested in here is the Madison River near West Yellowstone, Montana. I usually find it easiest just to work directly from Google for these searches. So if I type in Madison River, West Yellowstone, NWIS for National Water Information Service, that'll get me some useful links for getting me to the data that I want. Now, if I go to this first link, open it in a new tab, this is going to take me to the older interface for getting at NWIS or NWIS data. But if you need to get to the water quality data from this link, you can find this box here that says available data for this site. Click on the down arrow, and we're looking for water quality field lab sample data. So these are samples that they've collected at this gauge, and they've analyzed those samples for electrical conductivity and total dissolved solids. If I click on that, that will actually take me to the newer interface for getting water quality data. And this is an interface for getting water quality data from the National Water Quality Data Portal. Recently, the USGS has translated all of their data that used to be in the NWIS system into the National Water Quality Data Portal. Now, if I go back to my search results and I go to the second link, you might end up on a page that looks more like this. And this is the newer interface for a gauge on the newer system for NWIS. Now, in order to get to the water quality from this page, you're going to want to go to the data inventory, and you'll see this detailed inventory link. If you click on that, that will take you to something that looks more like the older USGS interface. And again, there's available data for this site. You can click on the down arrow, and here's that water quality and the field lab samples. So again, if I click on this, it's going to take me to the same web page for querying the National Water Quality Data Portal. If you get to this water quality web page from a particular gauge, then you should see that the gauge number is already filled in for the monitoring location identifier that you're going to be searching for when you look for water quality data. If that isn't filled in, you can always fill it in. You just need to put in USGS- for a USGS gauge, and then the code for that gauge. In this case, this is the correct code for the Madison River at the gauge near West Yellowstone, Montana. So we're going to pull data for this gauge. There are other ways to query data from the system. You can do it by state or territory. You can do it by site types. You can also do it by coordinates, bounding coordinates, or even hydrologic unit codes. But in this case, we know exactly which gauge we want data for, so just filling that in is all we need to do for getting data for this particular gauge. Then we also have ways to fill in result filters, and this is for the particular data that we're looking for that gauge. And in this case, we're really interested in these observed properties. We want to put in particular observed properties because we know which data we're looking for. Now, this particular data system makes it a little bit challenging to figure out exactly which observed property you're interested in. So we've actually provided that information to you in the template for the spreadsheet, where we've already got it typed out. We want the specific conductance of water, unfiltered, normalized to 25 degrees Celsius. And we also want the TDS, or the dissolved solids of water, filtered, and the sum of the constituents. So these are the two codes that you would eventually find if you search through the different codes that are available on the database. But I'm going to save you the time trying to hunt those down. This is really what we're looking for. And that means I can just cut and paste the text directly from the spreadsheet into the web page. So first I'm going to get the code for the electrical conductivity. I'll switch back to my web browser. And as it says, I can start typing, or in this case, I'll just paste in the field. And if I've typed it in correctly and I hit enter after pasting that in, then it will have found that particular observed property and filled it in for me in this box. If I had typed it in wrong and put in something invalid, it would not have left this gray box here. So that is for specific conductance. I can then go back to the spreadsheet. I can get the code for TDS. So I'm copying this code, dissolved solids, water, filtered sum of constituents. I can go back to the web page and then add another code. And again, hit enter. And now I see I've got these two gray boxes with the codes filled in for the two different observed properties that I want to pull for this particular gauge. I can also limit the dates I want here, but in this case, I'm going to leave these blank because I want all the data that are available for this particular gauge in terms of these two observed properties. So it's a fairly simple query tool in terms of pulling the data you want. There's one last step that you need to do to get the data, and that's select a particular data profile. So you can use this query tool to just find out which monitoring locations have particular data or which activities have happened at given monitoring locations. But in this case, we want to get the actual data or get the results. So under the data profiles, in order to download some data, we want to pick results. And these data tables are going to have a whole lot of extra metadata in them, or things describing the data that you actually want. And the type of table that we want to get to limit the number of columns of stuff that we don't need is going to be the narrow results. So you want to pick results, and under results, you want to pick narrow. Now, once you've filled all of this in, it's going to give you the URL that you can use to conduct this query. So you could just cut and paste this into a web page to pull the data, but we can also just click this download button to go ahead and execute this query and get the data. So I'm going to click download, and my web browser should ask me, where do you want to put this file that we're about to download, and what do you want to call it? So I'm going to stick this file in my downloads for now, and later on I will copy and paste this file to where I need it to do the analysis. And just to make sure I know what these data are, I'm going to call it Madison River _ WQ for water quality. So I'm going to put Madison River WQ in here, save. And now that is in my downloads, and I can use it later for analysis. Just so you see what this data file looks like, I'm going to go ahead and click on my downloads. I'm going to open up the folder where the download occurred. Here's what that folder looks like, and here is the Madison River _ WQ. And I'm going to go ahead and open this up in a text editor, because this is just a text file, comma delimited text file. And you can see that each row is a row in a table, and there's comma in between all of the columns. So as you can see, there are a lot of different columns here in this particular table. And there's only certain columns that we're going to need to work with. And we'll figure out how to extract the columns that we want to work with when we get into importing this data into Excel. So this is what it looks like in a text editor. You can also open up CSV files in Excel just to see what the table looks like in terms of all of the data. So we will look at this in more detail when we import this data into Excel.